All right, margin of error now. Okay, so remember our margin of error is calculated as E equals ZC times sigma over the square root of n, where everything is given here. Now we're given a 90% confidence level. Now to get ZC from that, we can just look it up on a chart. The other way is like in the previous problem, we would have to find out when 90% is in there. But we have some common values that we're familiar with. So this would be a 1.645. So I get 1.645 times 10.2 over square root of 75. And that is going to give me approximately 1.94, which is A. All right, and then we're going to get a confidence interval. So that's one step beyond the margin of error. I just need to get the margin of error and then add it and subtract it to the sample mean. Okay, so we have a random sample of 40, n is 40. We have x bar of 81.5. Population standard deviation, so sigma is 10.2, and we're going to use a C value of 0.90. The meaning for us is that the critical Z value will then be 1.645 as we used above. Okay, so E, margin of error, is going to be ZC times sigma over the square root of n, which is going to be 1.645 times sigma is 10.2 over the square root of 40. And that is approximately about 2.7. So then I'm going to take x bar and subtract that epsilon, and I mean that E, and add that E. All right, so if I take 81.5 and subtract 2.7, and then take 81.5 and add 2.7, what I'm going to get is 78.8 and 84.2, and that's how I get my confidence interval. All right, let's see. Recent study of 67 eighth graders, mean number of hours per week they watched was 17.5. Assume the population standard deviation is 5.4 hours. All right, so the first thing that we're going to get is a 98% confidence interval. All right, what have they told us? They've told us that n is 67. They've told us that x bar is 17.5. And sigma was 5.4. And they want 98% confidence. So that's a C of 0.98. And if we look that up, we'll get a critical Z value of 2.33. Okay, so first we find our margin of error, CC, sigma over the square root of n. 2.33 times 5.4 over square root of 67, which is about 1.5. So then I just take x bar and subtract that off and add that to it. So we had 17.5 minus 1.5, 17.5 plus 1.5. So we would get 16 here, and 19 here. All right, and what if the standard deviation is doubled? What would be the effect on the confidence interval? Okay, so let me just answer B. This was all A here. If you double the standard deviation, look at the margin of error there, you're going to be doubling the margin of error. So everything else is staying the same. So you're going to be making the margin bigger. So you're going to be making these numbers twice as big here. This is going to will widen the confidence interval. Okay. A nurse at a local hospital is interested in estimating the birth weight of infants. How large of a sample if she desires 99% confidence that the true mean was within 4 ounces of the sample mean. Standard deviation known to be 9 ounces. So let's see what they've given us here. They've given us a C of 0.99, which, if we look it up, will give us a ZC of 2.575. All right, and the true mean is within 4 ounces. So they're giving us a margin of error of 4. And the standard deviation, they're telling, is 9. So before we were calculating the margin of error, this time we're trying to figure out what should n be. So we're going to go backwards here. We have a formula for that. We have n is ZC sigma over E all squared. So we would be doing 2.575 times 9 over 4 all squared, which would give us about 33.6, but we can't make a sample size which has a decimal in it. So we're going to have to round this, and in order to ensure that we meet the confidence level, we're going to have to round up, and so we round this up to 34. That was C. Okay, given the sample statistics, the same sample statistics, which level of confidence would produce the narrowest confidence interval? 75%, 85%, 90%, or 95%? Okay, so remember, if you're looking for the confidence interval, if you have the same sample statistics, if you want to get a higher level of confidence, then you're going to have to open up the interval so you give yourself more leeway. So if you're trying to see which one would be the narrowest, that's the 75%, because we don't need, we're not really requiring as much confidence there, so our interval can be smaller.